In this lecture, we are going to discuss about binary arithmetic. Binary arithmetic means we are going to discuss the four arithmetic operations. They are performed on the binary numbers. The first is the binary addition, second is the binary subtraction, third is binary multiplication, and fourth is the binary division. So first we are going to discuss binary addition, and while doing the binary addition we have to see the two bits. The one is called as OGEND and the another is called as addend. So what is OGEND? OGEND is the number in which the another number need to be added. And what is addend? Addend is the number that need to be added to OGEND. So that means if we are adding the two numbers, that is number 1 and number 2. So number 1 can be considered as OGEND and the number 2 that is considered as addend. So if we talk about binary, in the binary we have two possibilities. Either the OGEND or addend can be 0 or 1. So like OGEND can be 0 and the addend is also 0, first possibility. Then second one, OGEND is 0, addend is 1. Then third is OGEND is 1 and the addend is 0. And the fourth is OGEND and addend both are 1. So there are four possibilities in total, because in the binary we have two possibilities, either 0 or 1. So OGEND and addend can have four combinations. Both can be 0 0 or 0 1 or 1 0 or 1 1. So we have to see if OGEND and addend both are 0, then summation of 0 and 0 will be 0. So 0 plus 0 sum will be 0 and there is no requirement of carry. In that case the result is also 0. And if we are adding 0 with 1, so 0 plus 1 summation will be 1. Again there is no requirement of carry and the result here is same as summation is 1, so result is also 1. And if OGEND is 1 and the addend is 0, in that case 1 plus 0 sum will be 1. Again there is no requirement of carry and the result here is again same as sum, that is 1. And when we are adding 1 with 1, so 1 plus 1 is 0, summation will be 0 and the carry generated will be 1. So how to write this result? That is, sum here is 0 and the carry is written ahead of sum. So carry here is 1. So we say that result of 1 plus 1 is 1 0. So we are applying these rules of binary addition while adding the two multi-bit numbers. So we are taking here three examples of binary addition. Like in the example 1, we have addition of two numbers. The first number in the decimal we are taking is 11 and the second decimal number we are taking is 12. So we have to add these two numbers via the binary addition method. So first of all we are converting decimal value 11 to its equivalent binary, that is 1 0 1 1. Then we are converting 12 to its equivalent binary, that is 1 1 0 0. So we are considering the number 1, that is 1 0 1 1 as OGEND and the second number 1 1 0 0 as addend. So how to add these two numbers? We start adding the numbers bit by bit, starting from the least significant bits. Like first we are adding 1 with 0. So we have discussed that 1 plus 0 result is 1 as sum is 1 and there is no carry. Then we are adding again 1 and 0. So again the sum will be 1 and there is no carry. Further we are adding 0 with 1. So again sum is 1 and there is no carry. And finally when we add these two most significant bits, that is 1 and 1. So sum here is 0 and the carry here is 1. So 1 plus 1 is 0 with carry 1. So we are adding the two numbers 11 and 12. So decimal should come out 23. And when we see the binary equivalent of 23, that should come out 10111. So in this way we can verify our result of binary addition. Then the second example we are taking is decimal number 5 and the decimal number 15 we need to add. So first we are converting 5 to its equivalent binary, that is 0101. Then we are converting 15 to its equivalent binary, that is 1111. So 0101 we are taking as urgent and 1111 we are taking it as addend. So what is 1 plus 1? That is 0 with carry 1. So carry is written at next consecutive bit position. So in the second bit position now we have 3 bits, 1, 0 and 1. So when we are adding 1 and 0 we get 1. Then 1 is added to 1, we get summation as 0 and the carry is written at next consecutive bit position. So now we are adding this carry with these two bits also. So 1 plus 1 is 0 with carry 1. So that carry is written at next bit position. So 0 is added with 1. So here we have result 1. Now we have to add 1 with 0, that is 1, and 1 plus 1, that is 0 with carry 1. So finally we get the sum as 10100. So 5 plus 15 should come out 20 and we are getting 20 equivalent binary as 10100. So you can verify this result that the binary equivalent of 20, that should come out 10100. So in this way we can go for the binary addition by applying the rules of binary addition that we have discussed in the last slide. And in the example 3 we are taking total 4 numbers of addition, number 1, number 2, number 3, number 4. So these 4 numbers we need to add. So as we have multiple numbers now, so the simple method that we have applied in this example 1 and example 2, if we apply the same method we can go for the binary addition, but that becomes very cumbersome, very complex. So to avoid the complexity and how to make this method easy, there is one solution to it. What we do, when we start adding these 4-bit numbers, so we see that how many number of ones are there in the addition. Like here if we are adding 0 0 1 1, so 2 ones are there, 2 ones, they are representing even value. So if we are adding multi-bit numbers and the number of ones are even, in that case remember that sum will be 0 and the carry generated will be depending upon the pair of ones. Like here we have one pair of ones, so one carry will be generated and returned to the next consecutive bit position. And if there are two pair of ones, so there will be generation of two carries. So depending upon the situation we can add the carries to the next consecutive bit position. Like here we have even number of ones, we have written sum 0 and as one pair of 1 is there, so one carry is forwarded. So here in the next bit position now we have how many ones? 1, 2 and 3. So total 3 ones are there in this bit position. So this is representing odd value. So for odd number of ones, sum will be 1 and as again we have one pair of ones, so one carry will be forwarded. And now in this bit position we can see this is first one and this is second one. Total 2 ones are there, even representation of ones. So we have summation as 0 and as one pair of ones is there, so one carry will be forwarded. Now in this bit position total we have how many ones? Total 4 ones are there. So 4 ones even value, sum will be 0. But now we have two pair of ones because 4 ones are representing two pair. So two pair will generate two carries. So here we put two carries in the next bit position. So in this column or in this bit position we see how many ones are there? 3 ones. 3 ones means odd value, so sum will be 1 and 1 carry will be forwarded. Here again we have 3 ones, so odd means summation will be 1 and 1 carry will be forwarded. Here also we have 3 ones, odd value, sum will be 1 and 1 carry will be forwarded. And finally also we have 3 ones, odd value, so result here will be 1 and 1 carry is forwarded. So final carry, that is written at the most significant bit position, and we see that we have added total 4 numbers. In the decimal their values are number 1 is 106, number 2 is 8, number 3 is 129, and number 4 is 255. So when we add these 4 numbers, result should come out 498. So if we calculate the binary equivalent of 498, that will be 1111100010. So in this way we can verify the binary addition of 4 numbers by the simple method, that is we need to count the number of ones in the addition. If number of ones are even, summation will be 0. If number of ones are odd, summation will be 1. And if we are adding one pair of ones, then one carry need to be forwarded, and if there are two pair of ones, two carry will be forwarded, and so on, depending upon the number of ones and the total numbers we are adding. Then next we have binary subtraction. So in the binary subtraction we have minuend and subtrahend. So what is minuend? Minuend is the number from which another number need to be subtracted, and subtrahend is the number which need to be subtracted from the minuend. So minuend and subtrahend can have again 4 combinations of bits, that can be 0 and 0, both minuend and subtrahend are 0, or that can be 0 and 1, or that can be 1 and 0, or both can be 1 simultaneously. So if both are 0, that means we are doing the operation 0 minus 0. So what is the difference there? 0 minus 0, difference will be 0, and there is no requirement of borrow. Borrow will be also 0. And if we are doing the subtraction 0 minus 1, so difference there will be 1 and the borrow requirement will be 1. So this is a very important subtraction point, that 0 minus 1 is difference is 1 with the borrow requirement 1. Then 1 minus 0 is simple, difference is 1, no requirement of borrow, borrow will be 0. And 1 minus 1 is difference will be 0 and the borrow is also 0. So these are the rules of binary subtraction that we can apply for the multi-bit subtraction. So here we are taking the two examples of multi-bit numbers. So we are taking two numbers in the binary subtraction. Number 1 we are taking is 11 and the number 2 we are taking is 6. So number 1 is considered as minuend and the number 2 is considered as subtrahend. So minuend value in the binary is written as 1011 and the subtrahend value, that is number 2, is written in the binary as 0110. So how to perform the binary subtraction? First we start subtracting from the least significant bits. So 1 minus 0, the difference will be 1 and there is no requirement of borrow. Borrow is written at next consecutive bit position here. So borrow is 0. So now we are subtracting 1 minus 1. So 1 minus 1, difference will be 0 and again there is no requirement of borrow. Then we have subtraction of 0 and 1. 0 minus 1, difference will be 1 and the borrow requirement is also 1. So here what we are doing is we are subtracting this 0 from 1, that is 1 minus 0. So 1 minus 0 is 1. Now we have to subtract this borrow from that difference. So difference of 1 minus 0 is 1. So that difference minus borrow. So 1 minus 1 will be 0. So finally we are getting the difference as 0, 1, 0, 1. So 11 minus 6 should come out 5 and equivalent value in binary for 5 is 0, 1, 0, 1. So in this way we can verify the result of binary subtraction. And in the example 2 we are doing the operation 35 minus 31. So in the binary subtraction 35 is written as 10001. This is number 1 considered as minuend, and the number 2 that is 31 that is written in binary as 0 1 1 1 1 and 1. This is considered as subtrahend. So how we are doing the subtraction? 1 minus 1 0, then 1 minus 1 0. Borrow here is 1 minus 1 is 0, borrow is 0. 1 minus 1 is 0 with borrow 0. Now we have 0 minus 1. 0 minus 1 is 1 with borrow requirement 1. So now the 0 need to be subtracted from difference. So here we have 1. Next we have 0 minus 1, that is 1 with the borrow requirement 1. So now 1 minus 1 will be 0. So that means the borrow need to be subtracted from difference of these two. Difference of these two is 1. So this 1 need to be subtracted from that difference. So final difference we are getting here is 0. So now we have 0 minus 1, that is 1 with borrow requirement 1, and 1 minus 1 is 0. And finally we have 1 minus 0, that is 1, and 1 minus 1, that is 0. So finally we get the difference as 0 0 0 1 0 0, and the binary equivalent here is 4. So decimal equivalent of 100, that is decimal equivalent is 4. So 35 minus 31 should come out 4 in decimal, and the binary equivalent is 100. Then next we have binary multiplication. So when we are multiplying two numbers, so number 1 is considered as multiplicand and the number 2 is considered as multiplier. So multiplicand and multiplier can have 4 combinations: 0 0 0 1 1 0 and 1 1. So what is the product of 0 and 0? 0 into 0 is 0. Same as ordinary mathematics that we are doing in daily life. Decimal multiplication: 0 into 0 0, 0 into 1 0, 1 into 0 is 0, and 1 into 1 is 1. So these rules we apply for the binary multiplication for the multi-bit numbers. So here we are taking two examples. In the example 1 we are multiplying two numbers, that is 11 and 5, and result should come out 55. So when we are doing the binary multiplication, 11 is written in binary as 1011 and 5 is written in binary as 101. So how we multiply? We multiply each bit of multiplier. Number 2 is considered as multiplier and number 1 is considered as multiplicand. So what we do here is we take each bit of multiplier one by one, starting from the least significant bit, and we multiply each bit of multiplier with multiplicand and write here the partial product. Like initially we take the least significant bit, that is 1. So this 1 is multiplied to this multiplicand. So when this multiplicand is multiplied to 1, we have same multiplicand 1011. So this is considered as partial product 1. Then we multiply 0 with this multiplicand, so that leads to complete multiplicand 0. So this particular partial product, that is shifted left one position by putting one cross mark at the least significant bit position. So here we have 4 zeros because 0 is multiplied to 1, 0. Then 0 is multiplied to this one, 0. 0 is multiplied to 0, 0, and 0 is multiplied to 1, this will be 0. So this is considered as second partial product 2. Now we multiply this bit, that is the most significant bit of multiplier, that is 1 to 1011. So we get here 1011. Now this partial product is shifted left 2 times by putting 2 cross mark here. So this is considered as partial product 3. So finally we are adding these 3 partial products by the binary addition method, and while adding these 3 partial products, this cross mark is considered as 0. So if we add these three partial products, here we have 1 0 0, result is 1. Here we have 1 0 0, so here also it is 1. Then next we have 0 0 1, this will be 1. Then next we have 1 0 1, sum will be 0 and carry will be 1. So 1 0 0 1, and finally we have 1. So 1 1 0 triple 1, that is final product, and its decimal value is 55. So in this way we can perform the binary multiplication. Then in the example 2, we are taking two numbers as 45 and 63 in decimal. So first of all they are written in binary, 101101, that is 45, and 111111, that is 63. So when we multiply these two numbers, so here we write partial product. How many partial product will be there? That depends upon number of bits in the multiplier. So in the multiplier total we have 6 bits. So we multiply each bit of multiplier with the multiplicand and write here partial product. So total we get 6 partial product, and each partial product is shifted left towards shifted left by 1 bit. Like here partial product is shifted left by 1 bit by putting 1 cross mark, and partial product 3 is shifted by 2-bit position by putting 2 cross mark. The next partial product is shifted left towards 3 times by 3-bit position by putting 3 cross marks here. Then next partial product is shifted left by 4-bit position by putting 4 cross mark, and finally partial product 6 is shifted left by 5-bit positions by putting here 5 cross mark, and finally we are adding all these partial products to get the final product, and we can verify its decimal value as 2835. 45 into 63 must come out 2835. Then next we have binary division. In the binary division we are taking two decimal numbers 117 and 9. So 117 is considered as dividend and 9 is considered as divisor. So 117 need to be converted to binary 111011, and 9 is converted to binary 1001, and here we write quotient and here we write remainder. So what we do, 1001, when 1110 is divided by 1001, here quotient will be 1, we write here 1001. So this 1001 need to be subtracted from 1110, as we have discussed the binary subtraction. So we can apply the binary subtraction here. So 0 minus 1 is 1 with the borrow requirement 1. Then 1 minus 0 is 1, and 1 minus 1, that is 0. Then 1 minus 0 is 1, and 1 minus 1 is 0. So this 1 is forwarded here. So we have 1011. So 1001, that is 1011, that is divided by 1001. So we get here quotient 1, and here we write 1001. Now this 1001 need to be subtracted from 1011. So 1 minus 1 is 0, 1 minus 0 is 1, 0 minus 0 is 0, and 1 minus 1 is 0. Now this 0 is forwarded here. So we get 100. So quotient here is 0. Now we forward one more bit, that is 1 here. So 1001. Here we have 1001. So quotient here is 1, and here we put 1001. So when this 1001 is subtracted from 1001, finally we get the remainder here 0000. So quotient we get here is 1101, and the remainder we are getting here is 0. So binary division is same as the decimal division that we do in the daily routine. So same way we can perform binary division. Only thing here we are going to use the binary subtraction method at each step. So before going for the binary division, binary subtraction must be clear, and it is very important to know that in the computer when we design hardware, so in the hardware we need the circuit for adder, subtractor, multiplier as well as divisor. So in that case, all the functions we can perform with the help of adder, because binary subtraction we can do with the help of binary addition. That method is called as ones and twos complement method. So that we will discuss in the next lecture. And we have seen that in the binary multiplication we have to add all the partial products. So in the binary multiplication we need binary addition. So with the help of binary addition method we can go for multiplication. Like if we want to multiply 5 and 4, so 5 can be added with 5 total 4 times, 5 plus 5 plus 5 plus 5. So result will be same, 5 plus 5 plus 5 plus 5, that will be 20, and 5 into 4 is also 20. So with the help of binary addition we can perform binary multiplication, and the binary division can be performed again by the binary subtraction, and binary subtraction can be further implemented by binary addition. So ultimately conclusion is that with the help of binary addition we can perform all the remaining arithmetic operations, that is subtraction, multiplication as well as division. So benefit here is that the hardware becomes very simple. Only we need the circuit of adder. With the help of adder we can perform any of the arithmetic operation. These are the references I have used. Thank you.